Water is the lifeblood that feeds the world around us. Water nourishes the plants and animals that make up the many diverse ecosystems throughout our world. Along with the rain, which brings much-needed nutrients, the rivers and streams carry lots of important life-sustaining products within the environment, including energy.
By drawing on the power of these natural rivers, we can acquire great energy that is eco-friendly and renewable. With facilities like the McLeod Dam, we have an excellent opportunity to harness green energy. But what is green energy? Green energy is power that is generated in a way that's not harmful to the environment and is renewable. At Quinte Conservation, we're committed to preserving and protecting our natural heritage throughout the Quinte region. By harnessing power at our existing dams that was previously unused, we are able to produce clean, green energy. Construction began on our first green energy project at the McLeod Dam on the Moire River in July 2007. The goal was to maximize the amount of energy generated and to install turbines to generate electricity.
Brian Keane is Quinte Conservation's Water Resource Manager and worked on the green energy project.
Well, the dam was originally constructed for ice control, so its configuration, its shape, was all intended to collect ice, and it had an overflow weir or a bypass weir. It was a concrete OG shape, and that weir needed to be raised in order for us to hold water level at a higher head. So one of the biggest parts of the project was installing this gate we call an Obermeyer gate. So that required a lot of effort. And then the other modifications were to create an intake and a generation room. Water was our biggest problem. Even though it's our biggest friend in green energy, when you're constructing in the river, it's one of your biggest problems. And it was something that I think caused us a lot of delay. You have to work in a river, so you don't know necessarily what the flow is going to be and how much that water is going to affect you. As they were getting to the turbine or generator room, we began to get more and more water. We were actually working below the water line, so we had to coffer dam off a lot of the river, and then we were working in the winter. So if it failed overnight, it would freeze up, fill up, freeze up, we'd have lots of ice in our work area. The Obermeyer weir at the end of the dam, that Obermeyer weir or gate is a little over 10 feet high on top of the existing weir. It helps us hold back upwards of 5 meters of water when we're operating at full head. It's fully adjustable. You probably saw some black pillows of big rubber bags underneath it. So those are air bags that are filled with air. They operate anywhere between 8 to 15 pounds of pressure per square inch. So not a lot of high pressure. The bags are a little over half an inch thick and could withstand a rifle shot or a shotgun shot. So they are pretty strong, and they're meant to last about 20 years.
Water isn't the only thing that travels downriver, which is why trash racks needed to be installed.
The old intake structure was underwater and wouldn't have had a trash rack associated with it. So because these turbines are fairly sensitive, we don't want a log going through and hitting these turbines. We have to put a trash rack in to sort of filter out the larger material.
Hydroelectricity is created by harnessing power from water. As water falls through a dam, it loses energy. One way to capture the energy is to place a turbine in the water's path as it moves through the dam. The greater the distance the water falls, the more energy is captured. Here's how it works. 2 Kaplan turbines were installed in the McLeod Dam. The force of water moving downstream turns the turbines that are connected via a shaft to the electrical generator at the dam that converts the mechanical energy into electric energy. The generator contains magnets and copper wire. The turbine shaft spins, rotating the magnets in the generator. The rotating magnets induce a current in the wire to produce electricity. Electric current from the generator at 600 volts is conducted to a transformer where it is stepped up to 13,800 volts for distribution. Power lines connect the dam to the existing power grid. Our homes, schools, and workplaces all demand a great deal of electricity. This demand can be harmful to the environment. By harnessing this new renewable energy, we will be reducing the equivalent of 5,000 tons of carbon dioxide each year from our air.
All of this clean, green energy will be fed into the local distribution system and used locally. Hydro revenues will be used by Quinte Conservation to pay for environmental projects that will improve the local environment and to further other hydropower projects.
For more information, visit the Quinte Conservation website at quinteconservation.ca or call us at 613-968-3434.